homes and factories of Thailand's worst floods in decades.
Billions of litres of water
around the capital Bangkok.
In 2011, heavy monsoon rains made the Chao Phraya River break through its embankments. Large parts of central Thailand were flooded, and soon Bangkok was threatened. Once the threat was imminent, experts from Delft, Netherlands, gathered with decision makers in Bangkok to try to reduce flood damage through emergency measures. These measures were partially successful, but total damages were $45 billion and GNP was reduced by 1%. 40% of the global hard drive production came to a halt and damaged supply chains around the world, further increasing total damages. Microsoft alone was said to have lost 100 million due to the flood. What if floods around the world could be predicted accurately, well in advance of the damage they may cause? In 2014, a global hydrological model will come online in the framework of the eWater cycle project. Imagine, in 2015, the famous city of Mandalay in central Myanmar is threatened by flooding of the eWater River. Now, thanks to the global hydrological model, early warning signs will go off 10 days before actual flooding occurs. Immediately, contact is sought with the mayor of Mandalay and the Dutch ambassador to set up communication channels.
After a quick agreement, additional satellite images are required of the eWater River basin to monitor the conditions upstream.
Detailed hydraulic model is started up to calculate exactly how the excess water will flow downstream, which floodplains will flood, and where the largest threats will occur. The hydraulic model was prepared offline for the whole globe so it can readily be integrated with the global hydrological model. The computational power needed is assessed and the necessary computer resources are acquired. Model projections quickly show that Mandalay will indeed flood if no additional measures are taken. Operational rooms are set up in Mandalay to communicate with the support center in the Netherlands. Video conferencing is set up. The mayor heads the emergency team with representatives of the Civil Protection Agency, Fire Department, Army and Police. Early on, one no-regret action becomes clear, being the heightening and reinforcement of the dike near Mandalay. This is the weakest link in the dike system that protects Mandalay. Bags and sand are transported. Volunteers and government workers start filling the bags. In parallel, economic and financial assessments are made of the effects that flooding would have on the different areas in and around Mandalay. Due to continued rainfall, the chance that strengthening the dike is sufficient to prevent flooding is reduced by the hour. Further measures will be needed. Traditionally, the depression north of Mandalay was flooded during large floods until it was embanked. The depression is a scarcely populated rice-growing area. The Civil Protection Agency is confident that it can move the 300 families that live there to safety within 36 hours. Damage estimates of the additional flooding run from $1 to $2 million. By breaking the dike, the flood peak can be stored in the depression, thereby preventing flooding of Mandalay. It is essential, however, that the timing of the dike break is such that exactly the peak is stored. Breaking the dike too early would mean that much of the storage is filled by the time the peak arrives. When the dike is broken too late, Mandalay will flood as well. Intense communication takes place between Mandalay and the Netherlands. Simulations show the best time to break the dike is Tuesday, 11 a.m. On Monday evening, the Civil Protection Agency gives the sign all clear. And at 11 a.m. the next morning, the dike is open. Erie flows into the depression and the peak of the flood is greatly reduced. The flood passes Mandalay without any significant damages. The extra lead time given by the eWater cycle's global hydrological model and the on-the-spot hydraulic simulations were essential in taking the right decision. Mandalay was safe.